I am Upender Karka, Assistant Professor, Department of Freshman Engineering, St. Man Engineering College. Today my lecture is on maximum minima of functions of several variables. So first I will explain what is the partial differentiation. So first z is a function of two variables x comma y, where x comma y are independent variables. Z is a function of two variables x comma y are independent variables, z is a dependent variable. Here the derivative of dependent variable with respect to the independent variable will be exist. Here x comma y are two independent variables, so the derivative of z with respect to the x comma y will be exist. So the derivative of z with respect to x, dou z by dou x, dou z by dou x is it is called partial derivative of z with respect to the x. It is denoted by small letter p, and the partial derivative of z with respect to the y is dou z by dou y. It is denoted by small letter q. These two, p is dou z by dou x and q is dou z by dou y, are called first order partial derivative of z with respect to the x comma y. Here dou z by dou x and dou z by dou y are functions of xy in terms of xy itself. So the partial derivative of dou z by dou x and dou z by dou y will be exist with respect to the x comma y. So the partial derivative of dou z by dou x with respect to the x is dou by dou x of dou z by dou x is dou square z by dou x square. It is the second order partial derivative of z with respect to the x. Here similarly dou by dou x of dou z by dou y, it is partial derivative of dou z by dou y with respect to the x. It is dou square z by dou x, dou square z by dou x dou y. It is a second order partial derivative of z with respect to the y and x ones. And similarly the partial derivative of z of dou z by dou y with respect to the y, dou by dou y of dou z by dou y, it is dou square z by dou y square. So it is the second order partial derivative of z with respect to the y. Here dou square z by dou x square we can denote by small letter r, and dou square z by dou x dou y we can denote it by small letter s, and dou square z by dou y square we can denote it by small letter s. Here p comma q are partial first order partial derivative of z, r comma s comma t are second order partial derivative. See here one observation. Here s is dou by dou x of dou z by dou y. Here first with respect to y we are performing the partial derivative of z, later with respect to the x we are performing. See here if we want perform, s is equal dou by dou y of dou z by dou y. Here first we are performing the partial derivative of z with respect to the y, later with respect to the x we are performing. So first with respect to the x, later with respect to the y we are performing. See here two times we are performing the partial differentiation, first with respect to the x, second later with respect to the y, that is dou square z by dou y dou x. When we are evaluating the partial differentiation for any function of two variables, if we by evaluating in any order, dou square z by dou x dou y or dou square z by dou y dou x, we can get the same answer. To understand these concepts, I will consider one example. Let one example I am considering to understand the concept of partial differentiation. Let z is equal to ax square plus 2hxy plus by square. Here what is the function? Ax square plus 2hxy plus by square. Here x comma y are independent variables. X comma y are independent variables. So that partial derivative of z with respect to the x comma y will be exist. So now I will evaluate all first order partial derivative as well as the second order partial derivatives. So dou z by dou x means dou by dou x of the complete function ax square plus 2hxy plus by square. So here we are performing the partial differentiation with respect to the x. It is nothing but a ordinary derivative with respect to the x, but only condition is we have to treat the other variable y as the constant. So think here a h b along with that a h b y is also constant. So with respect to the x we are performing. So dou z by dou x of ax square. Here a constant, dou by dou x of x square is 2x. 2x into a 2ax plus as it is. Next, dou by dou x of 2hxy. Here 2h as well as y constant, 2hy into dou by dou x of x. So 2hy into 1 plus dou by dou x of by square. Here b constant as well as y constant. So derivative of a constant will be 0. So plus 0. So finally the dou z by dou x means partial derivative of this function with respect to the x is 2ax plus 2hy. So just now I told that dou z by dou x also we can denote by small letter p. So p is 2ax plus 2hy. Similarly, we can find out the partial differentiation of the given function with respect to the y. With respect to the y. So that is dou by dou y of ax square plus 2hxy plus by square. So here we are performing the partial differentiation of this function, complete function with respect to the y. By treating the other variable x is a constant. So here a constant, h constant along with the 2, b is also constant, x is also constant. So dou by dou y of ax square. So here we are performing the partial differentiation of with respect to y of the function ax square. Here a constant and x constant. So dou by dou y of ax square will be 0 plus dou by dou y of 2hxy. In this 2hxy with respect to y, 2h and x constant. So dou by dou y of y is 1. So 2hx into 1 plus dou by dou y of by square. Here b constant with dou by dou y of y square is the 2y. So it is b into 2by will b into 2y. 2by will get. So answer is 2hx plus 2by. This is these two are first order partial differentiation of the given function. Here dou z by dou y denoted by q. Next go for the second order partial differentiation. So that is dou by dou x of dou z by dou x. Already we evaluated one time, that is dou z by dou x with respect to x we are evaluated. Once again we are evaluating the partial differentiation with respect to the x, that is dou by dou x of dou z by dou x, that is equivalent to dou square z by dou x square, that is equal to dou by dou x of all we have the answer dou z by dou x. What is the dou z by dou x? Dou z by dou x is 2ax plus 2hy. Here we are performing the partial differentiation with respect to the x, means we have to treat the other variable y as the constant along with the a comma b constants. So here dou by dou x of 2ax, here 2 and a constant, 2a into dou by dou x of x 1. So that is 2a into 1 plus dou by dou x of 2hy. Here 2h and y constant. So derivative of a constant is 0. So final answer is dou square z by dou x square, answer is 2a. Similarly, dou square z by dou x dou y, that is nothing but dou by dou x of dou z by dou y. Here already we are evaluated derivative of z with respect to the y ones. Next we are evaluating the partial differentiation with respect to the x, that is dou by dou x of dou z by dou y value is Answer is 2hx plus 2by plus 2by. See, here we are performing the partial differentiation with respect to the x. Means the other variable y we have to treat as the constant. So, dou by dou x of 2hx is 2h plus dou by dou x of 2by is 0. So, answer is 2h. So, dou square z by dou x dou y is 2h. Similarly, dou square z by dou y square. It is dou by dou y of dou z by dou y. Dou z by dou y. So, we have dou z by dou y value. Dou z by dou y, what is that? 2hx. Dou by dou y of 2hx plus 2by. So, with respect to y we are performing, we have to treat the other variable x is a constant. Dou by dou y of here 2h x also constant. So, dou by dou y of constant is 0. Dou by dou y of 2b into y. So, 2b constant, dou by dou y of y is 1. So, finally, dou square z by dou y square is 2b. So, this is the example to understand the basic concepts of partial differentiation. Basic concept of partial differentiation. So, now I will go for the one more definition, that is chain rule and total derivative. Chain rule and total derivative. So, what is the, see here, suppose z is a function of two variables u comma v. U is also function of x comma y. U is also a function of two variables. So, here z is not a direct function of x comma y. Z is a function of functions. So, here z is called the composite function of x. Z is the function of composite function of x here. So, z is a function of u comma v. U comma v are functions of x comma y. U comma v are functions of x comma y. So, here z is not a direct function of x comma y. This is called the composite. Z is a composite function of two variables x comma y. Z is called the composite function of x comma y. So, in this case, how to evaluate the partial differentiation? In this case, how to evaluate the partial differentiation? See, here dou z by dou x. Dou z by dou x means partial differentiation of z with respect to the x. Partial differentiation of z with respect to the x. Here z is a function of u comma v and u comma v are functions of x comma y. So, the partial differentiation of z with respect to x is dou z by dou u into dou u by dou x plus dou z by dou v into dou v by dou x. Why we are using we are getting two terms here? Here z is a function of two variables u comma v and u comma v are functions of x comma y. V is also function of x comma y. See here, z is called composite function of x comma y. So, the partial differentiation of z with respect to the x and with respect to the y will be exist. That is dou z by dou x is dou z by dou u into dou u by dou x. Why we are getting the partial differentiation here? Here z is a function of two variables, more than one variables. So, in case of functions of several variables, the partial differentiation concept will come. That is why we are getting the dou z by dou x. So, is equal dou z by dou u into dou u by dou x. Here z is a function of x through u as well as the through v. So, along with u as well as along v, we can evaluate the partial differentiation. That is why we are getting the plus in between these two terms. Similarly, we can find out the partial differentiation of z with respect to the y we can evaluate. So, dou z by dou u dou y is dou z by dou u into dou u by dou y plus dou z by dou v into dou v by dou y. These two are called the partial partial differentiation of z with respect to the x comma y, these two are called the chain rule of z with respect to the x comma y. These two are called the chain rule of the partial differentiation. Next, one more important definition, total differential coefficient. In this case, see here, z is a function of two variables x comma y. Z is a function of two variables x comma y, but here again x comma y are function of one independent variable t. It is a, here also it is, that is a composite function of t only, but see here finally only one independent variable, t. So here derivative of z with respect to the t will be exist, but here only one independent variable. So in this case dz by dt only will exist. In case of single variable, the ordinary derivative will come. So that's why dz by dt will be exist. How we can evaluate dz by dt? Dz by dt is equal to dou z by dou x into dx by dt plus dou z by dou y into dy by dt. Here we are using one place d, another place dou. Dou represents partial differentiation, d represents ordinary differentiation. In case of function of single variable, ordinary derivative, that we can represent by d. In case of functions of several variables, that is more than one variables, in that case partial differentiation will come, that we can represent by dou. So that's why here dz by dt is equal to dou z by dou x into dx by dt plus dou z by dou y into dy by dt will come. So here dz by dt we can write dz is equal to dou z by dou x into dx by dt, and dou z by dou y into dy by dt we can write dy. So this is the, here dz is called the total differential coefficient of the z. So this is the explanation about chain rule of partial differentiation and total differential coefficient of the z. See here, next I am going to start the maximum minima of functions of several variables. How we can find out maximum minimum of functions of several variables. Suppose z is f of x comma y is a functions of two variables, x comma y. For this function, how we can find out the maxima minima? What is the maxima? Maxima is the value of x at which the function have maximum in the given interval. What is the maxima? Maxima is the value of x at which the function will get maximum. So here maxima minima of functions of two variables. F of x comma y, a given function for two variables x comma y, at x is equal to a and y is equal to b, the function f of x comma y is said to have maximum or minimum if f of a comma b greater than f of a plus h comma b plus k, or f of a comma b less than f of a plus h comma b plus k. The meaning of this is, for every value of x at a point a comma b, the function will have maximum to the other point, then we can say that point is maximum. Less than, then we can say the point is minimum. How to find out maxima or minima of functions of two variables? What is the procedure? First we have to find out the partial differentiation of two given function f of x comma y. So that's why we have to find out the dou f by dou x and dou f by dou y, and we have to equate the two equations to 0, and we have to solve for x comma y. From that we can get the stationary points. By solving the partial differentiations dou f by dou x and dou f by dou y, we get the stationary points, we get the values of the x comma y ordered pair. That points are called the stationary point. At each stationary point we have to find out the second order partial derivative values, that is L, M, N. L is dou square f by dou x square, M is dou square f by dou x dou y, N is dou square f by dou y square. Here we have to check the condition, that point is either maximum or minimum. At that point we have to check the values ln minus m square, L into n minus m square. If it is greater than, and the value of L means dou square f by dou x square at that point is great less than, then the point is said to be minimum. And ln minus m square is positive greater than 0, and the value of L, that is dou square f by dou x square, is greater than 0, then the point is said to be minimum. If ln minus m square is less than 0, then the point is neither maximum nor minimum. The point is neither maximum nor minimum means that is not extreme. Next, if ln minus m square is equal to 0, then the further investigation is required. Means by using this method, we can't give the conclusion to find out the maximum and minimum. So now I will explain one example to understand, to find out the maximum or minimum. See here, I am considering a rectangular box with open top, and the volume of this rectangular box is 32 cubic feet. So we have to find out the dimensions of the box for least material construction. So here we are finding the, first we have to consider the surface of the rectangular box. S is equal, here the top is open, that's why we are not getting the 2 here. So here S is equal to x into y plus 2yz plus 2xz. Volume of the rectangular box is x into y into z. That was given in the question, that 32 cubic feet. So from these two equations, here S is a function of three variables x comma y comma z. We have to eliminate the third variable z. Using the equation 2. From this xyz is equal to 32. So from this equation z we can get 32 by xy. We can substitute these z value from the equation 2 in the equation 1. Then we can get the surface equation in terms of two variables x comma y. Then we can find out the partial differentiation of S with respect to the x comma y, and we can equate these to 0. Then we can get values of the x comma y that are called stationary points. At that point we can check the ln minus m, L value, m value and n value. Then we can find out the ln minus m square. Here we are getting the L value, L is equal to 2 and m is equal to 2, then m is equal to 1. There we are getting ln minus m square, 2 into 2, 4 minus 1, we are getting 3, it is a positive, and L is equal to 2, it is also a positive. So here ln minus m square positive and L is positive. Therefore, at x is equal to 4 comma y is equal to 4, the function will have the maximum. What is the L value? L is equal to 2, it is also positive. Therefore, at this point the function will have the minimum value. So here we have got only two values of the two variables x comma y. By substituting these x comma y values in the equation 1, we will get the z. So from that we can get the dimensions of the box. X is equal to 4, y is equal to 4 and z is equal to 4. Next, here if we want to find out the maximum minima of functions of three variables with some condition, in that case how to find out the maxima minima? So in here we can use the Lagrange's method of undetermined multiplier. In this case, suppose we want to find out the maxima minima of f given function f of x comma y. In that, the given condition is pi of x comma y comma z equal to 0. So first we have to form the Lagrangian function. Capital F is equal to small f plus lambda into pi of x comma y comma z. Then we have to perform the partial differentiation of capital F with respect to the x, y and z. So that is dou f by dou x, dou f by dou y, dou f by dou z, and equate to 0. So using these three equations, equation 2, 3, 4 and the equation 1, that is pi of x comma y comma z equal to 0. Using this equation 1, 2, 3, 4, by solving that we can get the value of the lambda. From that we can get the values of x comma y comma z. At that point the function will have the stationary value. So here I am solving this here. Here this is a function. So to understand the concept, I am considering one example. So in the plane x plus 2y plus 3z equal to 4, I want to find out a point which is near to the origin. So that here P is any point in the plane, O is the origin, then the distance between the origin and the point OP is equal, this is the equation. I am taking the square root of this OP, I am taking the function U. So here we have to find out the minimum of this distance between the origin and a point. So here here this is the condition. In this plane we have to find out the point. So we have to use this condition. So here we have to find out the maxima or minimum of the function u is equal to x square plus y square plus z square, and we have to use the condition phi is equal to x plus 2y plus 3z minus 4 equal to 0. So this become the f, small f, and this become the phi. Now we have to form the Lagrangian function capital F is equal to small f plus lambda into phi. So now I formed this equation. Now I can evaluate partial differentiation dou f by dou x and equal to 0, dou f by dou y and we have to equal to 0, dou f by dou z and we have to equate to 0. So we are here evaluated and equal to 0. From this I got the conclusion x, y, z in terms of the lambda. So finally here lambda is unknown. We have to get the lambda first. So by solving this, by substituting these x comma y comma z values in the equation 1, that is in the pi, so we can get the lambda value. See here, x is equal to lambda by 2, y is equal to minus lambda and z is equal to minus 3 lambda by 2. What is the equation 1 here? Equation 1 is, see here, this is the plane. This is x plus 2y plus 3z minus 4 equal to 0. In this equation, we have to substitute the x, y, z values in terms of the lambda. From that, we will get the lambda value is minus 4 by 7. See here, by taking the lambda is equal to minus 4 by 7 in this equation x, y, z value, we get the x comma y comma z. This is the point p of x comma y comma z. This is x value, y value and z coordinate value. This is the point which is near to the origin in the plane x plus 2y plus 3z equal to 4 equations. So this is the way to find out the maxima minima in case of function. Now I will explain how to find out the maxima and minima of functions of several variables. So I will consider a video here. So here I covered the maximum minima of functions of several variables using the Lagrangian method of undetermined multipliers. Here how to find out the maximum minima of functions of several variables. So maximum minimum of functions of several variables using the Lagrangian. Here normally if there is no condition, directly we can find out the maximum minimum. But the condition was given in terms of the variables. In terms of the variables we have to find out. So here maximum minima of functions of several variables. So here I am considering the function f of x is 2x to the power of 5 minus 13x power 3. Here I am taking the interval is minus 3 to 3. I am drawing the curve for this function in the interval minus 3 to 3. So here I am trying to explain what is the extrema. Extrema is either a point, extrema is a value of x which is either maxima or minima. In that case, what is the global maxima and what is the global minima? See, in this interval, what value of x? The function getting the maximum. See here, at x is equal to 3, the function getting the maximum in the entire interval. So the x is equal to 3 is called the point is called the maximum point. At that point, the value of the function is extremum. And in this interval, for what value of x, the function getting the minimum, that is global minimum. Here global minimum is the value of x at which f of x has smallest value in the entire interval. So at x is equal to minus 3, the function getting the minimum value in the entire interval. So that x is equal to minus 3 is called the global minimum. So here global maximum is the 3, global minimum is minus 3. Similarly, what is the local maximum? what is the local minimum. Local minimum is a value of x at x is equal to, at which f of x is, at which f of x is largest in that near, in this near only. See here f of x maximum at x is equal to 3 and here f of x is equal to maximum at x is equal to minus 2 also. See, but x is equal to, at x is equal to minus 2, at x is equal to minus 2, it is not maximum. X is equal to minus 3 is maximum. So in this in this surrounding only it is maximum, it has the maximum. And in the same way at x is equal to 2, the function has the maximum. So at x is equal to, x is equal to 2 is called the local maximum, x is equal to 3 is called the global maximum, x is equal to minus 3 is the global minimum, x is equal to minus 2 is the local minimum. So with this example I explain how to find out the extreme. So in this lecture I concluded that I explained so how to find out the partial differentiation, chain rule and total derivative, and also I explained how to find out the maxima minima of functions of two variables. So this is conclusion of my lecture. Thank you.